Good afternoon, participants. Good afternoon, Abhinav sir. Am I audible, sir?
Yes, ma'am. You're audible.
So, sir, I will introduce yours first. Then after that, you can start your session, sir.
All right.
So, uh, thank you, sir, for accepting our invitation for the FDP. So, it's my pleasure to introduce Mr. Abhinav, sir, for today's FDP session. So Mr. Abhinav Karan is having more than 4 years of embedded system and IoT experience in all phases of the software development lifecycle, including requirements analysis, project planning, development, firmware validation, firmware testing, hardware validation, and hardware testing. And also, he's having around more than 8 years of academic corporate training experience. And sir is now presently assistant professor in the Department of Electronics and Communication Engineering at Dayanand Sagar University. Sir also conducts various corporate training for both freshers as well as experienced professionals related to industry in the domain of C, C++, data structures, algorithms, Python, embedded firmware, development using C and C++, real-time operating system, Linux device driver, embedded Linux, data analytics, artificial intelligence in the computer vision and NLP domain, and also Internet of Things and edge computing, advanced driver assistance system technologies. So, sir is associated with various corporate organizations such as Harman Connected Services, Harman International, UST Global, LG Soft, Dover Corporation, Tata Elxsi, and also with Indian Air Force. So, thank you, sir, for accepting our invitation and for your valuable time. Over to you, sir. You can start your session.
All right. Thank you, ma'am, for the introduction. So, good afternoon, everybody. So let me share my screen, and we'll have a just small introductory session followed by hands-on. One second. Yeah. Can anyone acknowledge if my screen is shared or
Visible,
not?
sir.
It's
Sure, sir.
visible. All right. So, good afternoon again, all of you. So, this session is mostly focused on how exactly can we host AI models on devices which are having low memory footprint. Mostly, when I say devices which are having low memory footprint, these are mostly microcontrollers that we are going to talk about. Till now, there were sessions wherein you have an idea about how exactly can you run or in a machine learning model on FPGAs. So FPGAs can also be considered as one of the core for developing an embedded systems. Similarly, we can also use microcontroller units to develop embedded systems as a where controller can be considered as a core, right? So now the things have uh, as we are aware that we know that embedded system is something wherein if you are making use of a microcontroller, the problem is all these microcontrollers are tightly constrained. So when I say tightly constrained means the resources are constrained. You don't have uh, enough memory. You have limited amount of memory. That is maybe in terms of RAM and ROM as well as the CPU speed, the clock at which the CPU operates, that is also limited. That is very limited. That is in megahertz clock cycle. So in this session, so what you're going to understand is how to create AI models, machine learning, deep learning models, and make them run those models, make them run on low power devices like microcontrollers, right? So how do you do that? What all technologies that have come up, which will enable all of you to do projects on this particular scenario, wherein you can host a lightweight machine learning model on microcontrollers, and uh, and what all tools which are also available, which are not covered in this session, that you can also look into coming forward, and you can try it on your own. All right. So I just named the session as embedded AI because this is where we are going to confluence embedded systems along with artificial intelligence that has been going on from day one onwards, right? But here we are specific to hosting a low memory footprint AI model or a inference engine on a embedded on a microcontroller basically. All right. So what is the objectives? What are the objectives of this session? So TF Lite, so all of you might be knowing about TensorFlow. So a cut down version of TensorFlow that is called as TF Lite, which is being used to create models that can run on microcontrollers. So we'll try to understand how to make use of TF Lite in order to create a model and make use of that particular model to run on a particular microcontroller. What is that microcontroller that you're making use of? Slowly I'm going to talk about it, right? And the second thing that you're going to discuss here is the IDE, the firmware, the embedded IDE, basically the integrated development environment, wherein we are going to develop the firmware and start configure it. How do you configure that IDE in order to ensure that that particular model that is created, that lightweight model is created, is going to run successfully on a target machine, right? So for inference, right? So what exactly is happening? How exactly is happening? You guys might have questions like how, if we have limited amount of computing power, a limited amount of memory, how can we train the model? So exactly what exactly happens that what is the flow, the process flow that is being followed in order to achieve this target that we're going to discuss first, and then we'll move towards the hands-on session, right? So, and the hardware that you're going to make use of is it's a development board from ST Microelectronics, that is STM32 F4 Discovery board. This is having an ARM Cortex M4 processor, which is having a floating point unit as well. All right. And what are the softwares that we are going to make use of in order to create a machine learning model, lightweight model, and deploying it? These are the two sets of softwares that we are going to make use of, and I'll show you how to use that. Right. So the first one is Google Collaboratory. This is something which is accessible to everyone because I think almost all of the participants out here, they have a Gmail ID. So if you have a Gmail ID, you can easily access Google Collaboratory, right? And in that collab, and the second thing software that you're going to make use of is this STM32 Cube ID, right? So this is the one which you're going to make use of for developing the firmware, which is going to be uploaded finally into the microcontroller for doing inference to check, right? All right. So actually, what is happening? So as I said, microcontroller is a device with low memory footprint and low compute power, and we know that. So whenever you're going to train a model, maybe it's a machine learning model or a deep learning model that requires a lot more amount of compute power, which is not possible if you do it on a computing systems like a microcontroller. Although it's a computing system, it has a CPU, it has got memory, but that is not sufficient to train a model and train and create a model. That's not possible. So what is the ecosystem that we make use of? Is what we are going to use a host system. So you can see that. So I basically call this as a host system. So this is basically a host system which we are going to make use of. The host system is nothing but it is your laptop or desktop, right? So in this host system, the one that you are going to use is the rest. What exactly you are going to make use of in the host system is to train in this host system. We are going to do the following things. We are going to train a model, right? And finally create a model. Okay. And not only that, after that, second thing objective of this is, so whatever model which is created, right, it will have its own extension. That model cannot be understood by the microcontroller, because since we know that the microcontroller is a digital system, the CPU can only understand in terms of zeros and ones. It has its proprietary binary extensions. So then next thing what you have to do is you have to convert this model which is created, whatever model which has been created after proper training, testing, and validation, that has to be converted into a C file, right? So that's the next thing that you have to do, that you have to convert it into a C file, and from C file, it will be converted to its corresponding binary file, right? And this binary file is basically finally uploaded into this particular microcontroller, right? And for creating the model, the platform that you're going to make use of, the deep learning framework that you're making use of, is TensorFlow. In TensorFlow, we are using a lighter version of another version of TensorFlow, much lighter version, that is called as TensorFlow Lite, which is basically responsible. This is basically responsible for creating a model which can be converted into a C file, uh, and finally into a binary file with a low memory footprint, right? So this is the final thing that we want. We want to create a binary file which will be of low memory footprint, and this is how we are going to proceed. This is the actual method that we need to follow, right? Okay, so the first thing that we need to understand, that how to create, objective is to create a model, right? And that after creating that model, convert that into a model of which will support TensorFlow Lite. So first we are going to create a model using TensorFlow. Then after that, from TensorFlow, what you're going to do is we are going to create a model using TensorFlow Lite, right? And finally, what you're going to do is you are going to create a C file, because this is what you're going to do. And all of these steps that I've said right now, if we are going to perform all those steps in the software, that is, I was talking about this Google Colab. So you're using Google Colab to perform all these three operations, right? So let's have a hands-on session right now, okay? And then you will get an understanding of how exactly these things work, right? So all of you, now what you can do is, just 1 second. So I hope all of you have got Gmail. You can log into your Gmail IDs. All right. So you can log into your Gmail IDs. All right. And then try opening the drive from here itself. Go to Google Drive. Just let me know, please, if you are following it. If I'm going fast, you can just tell me, that I can again repeat the steps in case if you missed on any particular step. All right. So what you do is you can see that here a new button is there. All of you have been knowing how to create a new folder, and name this folder as, I'm naming it as a embedded demo, and you can name it whatever you think is suitable for you. So create that. So his folder is created inside Google Drive. All right. So once you are inside the folder, Google Drive folder, just right click, and you have an option called as more. Okay. So I think most of you will have this option. If not, how many of you are not having this option? Please let me know. Anyone who is not having this option, Google Collaboratory, you can raise your hands. If not, then you can see just below. If you don't see this option, Google Collaboratory, what you can do is something called as connect more apps, right? So you can click on this. Yes, and you go to collaboratory. You can just type. It will automatically Drop down will come, and you can select this, right? And for me, it is showing installed. That's why I can see that when I do right click. If not, you can install it, right? Just click on this, and you will have an option. For me, it is showing uninstall because I've already installed it. But people who are not installed, they can install it. All right. So I'll just do one thing. I'll just go to more, right click. I'll go to more. I'll go to Google Collaboratory. Right. So I can see that a file is getting created with an extension that is called as IPYNB, right? So this is the notebook extension, right? So for Google Collaboratory, and you can name this file as well. You can name this file as well. Edge underscore DL model. So you can name it as edge underscore DL underscore model. So automatically it will be saved. It will be saved. And if you just check your Google Drive folder, see, you can see that previously it was empty. Right now it is populated with this IPYNB file, right? I hope all of you are able to do it. So is there any way wherein you can show me a thumbs up or something so that I will proceed? I get to know that you are also doing along with me. All right. Okay. So, all right. So in this particular, what is the objective of creating this file is to create a deep learning model on TensorFlow using TensorFlow framework. And TensorFlow also, you're going to make use of Keras library in order to create a neural network architecture and convert that into a TensorFlow Lite model, and followed by converting it into a C file. That's what we are planning to do, right? Okay. So first, what you're going to do is we are going to check the version, right? That we're going to make use of. So you can type that one TensorFlow version that we're going to use. All right. And one more thing you have to do, I forgot to say that you can see there is a connect option here, right? Can you see that? You can see my cursor. There's a connect option here, right? So if you once you run this also, there's a play button here. You can just after writing the instruction, you can click on that. So the keyword shortcut is Shift Enter, right? So I will show you. First, you press connect. So as soon as you press connect, some amount of resources, cloud resources are allocated for this particular instance of IPYNB file. And if you want to see the details also, you can see view resources, right? How much amount of RAM and how much amount of ROM disk space has been allocated. So 12 GB of RAM is allocated and 107.7 GB of ROM is allocated, right? All right. Now, the thing is, why we have chosen this particular platform, the reason is uh, there are a lot of libraries which are already pre-installed, the deep learning and machine learning libraries. We don't have to create an environment for doing a project. So that is already been taken care of. So you don't have to waste much of your time into creating installing libraries and everything. So it is already there pre-built for you. You just have to create this file and start making use of those libraries as per your requirement and start coding. That's what, right? And the programming language that you're going to make use of is Python. Right? That's a programming language that you're going to use. All right. Okay. So now, next, what you're going to do is we are going to import some libraries. So I hope you guys have some idea about how to import libraries using Python, right? So we use this command called as import, and the library that you are going to make use of is that you are going to use TensorFlow, all right, as TF. So what happens is this is the keyword, the command that we make use of, that is called as import, and this is the library, and this TF is nothing but it's an alias, right? That we give it to this particular library. So we don't have to anywhere. If you have to make use of this particular library, you don't have to type the entire name. Instead, we can make use of this particular acronym or the alias that we have used right now. So import TensorFlow as TF. So we can use TF instead of TensorFlow, right? Then after that, we are going to import one more library for mathematical operations. That is NumPy. So NumPy is a library which is a very popular library which we make use of, right? Okay, so this is basically used to do mathematical operations, arithmetic operation, matrix operations. As we know that when you are dealing with machine learning models, when you train the model, there are a lot of mathematical computations that is required, which is taken care of by NumPy. Right. Then, so we also will be showing you some plots. So there are some visualization libraries like Matplotlib, Seaborn, Plotly, but the one that you're going to make use of here is Matplotlib. So we are going to import this Matplotlib library. Matplotlib.pyplot as PLT. All right. So you can use it. And there's one more library when since you are going using mathematical computations. So there's a math library that we need to implement. And there is one from TensorFlow. There is one from TensorFlow. Inside TensorFlow, there is one more sub library that is Keras, where I have to implement something called as layers, which will be used to define the architecture of the neural network model, right? So from TensorFlow dot Keras import layers. So once you've written, just execute this. So you can see that you just can use keywords outputs, shift enter. So when you do that, it will execute the current cell, and a new cell is also created for you. So wherein you can further write the code. Just see this warning here. Put missing imports. Okay, we see yourself. Right now, I just want to check as in when you can. So there is a lot of libraries that you have imported, and these libraries are constantly being upgraded, and there is always a revisions to the version of library that we make use of. If you want to find out what all versions of library that has been imported, we can also check that by printing the versions as well. So we can just print versions. Python versions TF. So these are some of the print command that we can print, and I want to also print the versions for NP, NumPy, math version, sorry, right, and the TF version NumPy, yeah, and print, Keras, not Keras version, right? So these are some of the versions. So these are some of the libraries that we have imported, and I think, right. So math doesn't have any version, so we can remove it. So you can see that. So the Python version that you're using is 3.11. TensorFlow version is 2.18. NumPy version is 1.26, and the Keras version that you're using, from where we have imported layers, is having version 3.8.0. All right. So these are the things that you're using right now. Okay. Now, next thing what you're going to do is, so we are going to basically, what kind of model that you are going to create here is, so you are trying to create a very simple model, which is going to, first you're going to generate a sine wave. So you're going to write a program which is going to generate a sine wave, and a model will be created to predict the sine wave values. So that's what is our objective here. But if you have to create a model, first you need to have an existing sine wave with all the data points, right? So which we are going to create right now. So we are going to randomly create a signal, and in that signal will be converted into a sine wave. So we'll look into that, how to do it, right? So what are the number of samples that you are going to implement? The number of, because if you have to train a model, you need some data points, right? Without that, you cannot create a model. So there should be an existing data, right? So what you're going to do is, in this piece of code, in this cell, we call this the place where you're typing this code, they are called as cells, right? So in this cell, what you're going to do is, we are going to set up some prerequisites for creating a model. So as in what, when I say that I'm going to use prerequisites, basically I will be defining the number of data points, all right? And what all, out of that data points, how many data points will be used for validation, how many data points will be used for testing, all right? And what is the name of the model? We are going to define the name of the model which we are going to create, okay? And and as well as the name of the model with .h extension, that is basically we are going to create a C library. So all these things we are going to define here, right? So we'll configuration settings. We'll name this cell as configuration settings. And whenever you want to write a comment in a particular cell, so you can use this hash. Uh, you can use this hash keyword, hash symbol, so that whatever you type after hash, that will be basically considered as a comment. So we are doing configuration settings. So now what I'm going to do here is, we are going to basically define the number of samples that you want to, you have to just create a data set. There's no existing data set. We are randomly creating a data set. So for that, the number of samples that is supposed to be present in that data set, so you have to define that. So we're going to create a variables n samples, okay? And let's say that we have 1,000 data points we want to include, all right? Then we have to decide on the amount of data out of 1,000 we want to use for validation, and the amount of data we want to use for testing. So 20% of the data, of the entire data, that is 100 data points, out of which 20% can be used for validation, and the remaining 20% can be used for testing. So for that, what we can do is, we can create two variables. So for validation, we are going to create a variable that is val ratio, and we are going to ratio is 0.2. That's basically 20% of the entire data set. That is 2200 uh, data points out of 1000 can be used for validation. And for testing, we can use this variable. Uh, 0.2, right? 0.2, 0. That's enough. Right. Okay. So once that is done, so what is the model name that you want to define? So what is the TF Lite model name that you want to define once you create that model? That is TF Lite. You can name that is equal to, you can name the model as sine underscore model. Okay. So you can name the model as sine underscore model. Then what you're going to do is, so what is the equivalent C model name? Because this file that is going to get created, the TF Lite file, after using TF Lite extension, so it cannot be understood by the microcontroller. So you have to somehow convert that into a C, and after doing post compilation, it will generate a binary file. But prior to that, before putting a file into compilation stage, so we need to convert that into a C file. So we can also name that C file which will be created, the C model name. All right. Okay. Sine model. So if you are not typing, and just can copy and paste it in the chat so that check. Yeah. So I have, you can just copy it and you can paste it in your notebook, right? So shift enter, so it will execute. There's no issue with the code till now. Just give me, anybody can acknowledge if it is done, so I can proceed. So till now we have not created any signal as of now. So as of now, we have no random samples are also not created. We are just settings. We are doing the settings here, wherein we are deciding how many samples will be there, and out of which the amount of the percentage of samples that are going to be used for validation and test, and what is going to be the name of the model, the C model as well as the TF Lite model. We are just doing some initialization, I would say. The model NumPy has no attribute version. There's this type of error is coming. Okay, so I'll do one thing. I'll paste this code snippet also. So I'll just copy this. Just try this, Abhinav, if you just can. It's fine. All right. Okay. So might be some typo, or that's why you are not getting. So now what you're going to do is you will generate some random samples. So you have decided the number of samples to be 1000. So what you're going to do is you have this library NumPy, right? Using NumPy, we are going to create some random samples right now. So what's that we're going to do in this cell is generate random samples. All right. So how are we going to do that? So NP, that is NumPy, NP. So you're not going to use the variable as the way in which we have imported the library, we have mentioned the alias name as NP. So we don't have to use the total name NumPy here. So we can use the alias name that is NP. So that's what. So here we are using in NP there is a function that is called as random, and in this having an API called as seed. Okay, so you're going to access that, and we are going to pass a seed value, and based on that seed value, the 1,000 samples that we have decided, it is going to be created, right? So that's what is happening, right? And so we are going to store all these values in this particular variable, that is x values. All right, and here we are trying to do a uniform uh, distribution. So I can just type it like this: np.random.uniform low height 2 into mat.py, right? And so basically, you know that so if it is a sine wave, right? If it is going to be a sine wave, it is going to the value is going to vary between 0 to 2 pi. Yes. So if it is going to be a sinusoidal signal, the data points that you're expecting, so it is going to vary between 0 to pi, 2 pi. So that is 0 to 180 degrees. So here you can see, so the lowest value is set as 0, and the highest value is set as 2 pi. This is 2 into mat.pi. And in between this range only, the number of the samples that is going to be created, it is decided by the third parameter, that is size. And the size, we are initializing it to a value that is n samples. So n samples is nothing but the value is 1,000. So in between this range, 1,000 random values are going to be created, but those values are not going to exceed 2 pi. In on the higher side, neither is going to be less than 0. It will not be towards the negative side, right? Okay. So okay, these things I can remove for now. That's not required. Okay. All right. And let us plot the values. So what are the values that we have generated? So we can do that. So for plotting, this is the visualization library. Visualization library is PLT, the alias name. But the actual visualization library that we are making use of is matplotlib. So that's what. So using PLT, we are going to basically plot the random samples in the form of a graph,
Abhinav
2D
sir,
graph. Yes. Yeah.
actually somebody asking, can you just zoom your screen?
Kindly
It does
maximize
not.
your screen. It's okay.
Uh,
Is it fine?
it's okay. I think it is fine.
It is fine, right? Avinash, can you just acknowledge if it is fine or not? Okay, fine. All right. So now this PLT dot plot. Okay. And what you're going to plot, the X values. What are the values? So that is generated. So that's what, right? And then press shift enter. So this cell will be executed, and you can say a 2D plot, and this is how the values are generated, right? So although I cannot consider this is not a sine wave, so we are first generating the random samples, right? And then after that we are going to convert this random samples in the form of a sine wave. I hope all of you will be getting these plots. So we're going to add some noise, and we are going to create a sine wave out of it. Okay, I'll do one thing. I'll just copy and paste this. So after execution, I will just copy and paste the cell so that you guys can. So this is what. All right. I hope you're getting. Okay, fine. So next, we have to transform this generated data in the form of a sine wave. So we have uh, a library in NumPy which we can make use of to generate sine waves. Okay. So, so this cell we are going to create a sine wave, and we are going to add some noise to it as well with x values. All right. So the sine wave that is going to be created, we are naming it as y values. All right. And we are going to pass an np.sine as of now. In that, the parameter that you are going to pass is the random samples, 1,000 random samples that are created, that is will within the range between 0 to 2 pi, right? And to this also you're going to add some minimal noise. Okay, and just doing that. So that's okay. np.random n, and here I'm going to use x values. All right. All right. Then I'll be plotting plot ELT.plot. Sorry, plot. So x values, y values. So this 0 basically represents the shape, right? So basically we have only one dimension. So this is one values that are getting created. So that's a 0. From 0 column, we are taking all the values. So that's what. And you are going to represent that in the form of a dot. So this is it. Let me execute this. So you can see this. So I'll just share this code. So all of you. So the whatever 1,000 samples that you are seeing here, that has now been transformed into a sine wave with some added noise. So this is the noise that you're adding. I've shared the code snippet in the chat, so you can see that. So this each point is a data point. So the total number of data points that you are seeing, these are 1,000. It's now representing a sine wave. So if all of you are getting the plot, anyone who is having any issues or anything. And if you want to know the data type of these variables, that is y values and x values. So in Python, we use this. I'll just show that is type. And since these are variables, each variable has got a data type associated with it. So I just type x values. So it is nothing but it's an n-dimensional array. So the values that got generated, which is getting stored in this variable. So it's nothing but an array. So it's a one-dimensional array. And similarly, y values, if you want to find out what is the data type of y values. So same way you can use this function type and you can check. So this is also an array. All right. So next, Next thing, what you're going to do is, so if you remember in the initializations, we have decided upon what are the total number of data points that are supposed to be generated randomly, which will be used to which will be used for creating a sine wave. So it is already set to 1000. Apart from that, we have declared two more variables, that is val ratio and test ratio. All right. So these are two variables which are basically wherein we have decided that out of 1000 samples, sample data points, 20% of the data will be going for validation, and remaining another 20% will be going for testing. So that means that 60% of the data which is remaining, that will be used for training. Right? Can anyone right now in here can tell me the difference between what is the difference between validation and testing? So why do you need two different? Why are you allocating this validation and testing? Can anyone tell me? Srichandra sir, they can unmute and they can speak, right?
Yes, sir. Yes, sir. They can
Okay.
easily unmute.
Okay. Fine. Anyone in
Anyone?
the hello? Now, why do we are splitting a data set into three parts? That is, one is for training, one is for validation, and one is for testing. So what's the difference between validation and testing? Why do you need a validation set? Why do you need a testing set? And validation set also in the, we call it as dev set, development set. Anyone? So we can type also if your mic are not it's not working. You can just speak up also, right? So validation set is also called as development set that we also use. So what happens is there are different types of validation techniques that we make use of before you test the model. So what happens is first we'll train the model. Then what you're going to do is while training the model in each epoch, right? We are going to further split the training data into some amount of data will go into validation, and some amount of data will go into what you say training, right? So let me give you an example here so that you'll get an idea. Let me go back to the slide so that you'll get an idea. Okay, so, so I can hear. So let's now in our case we have total of 1000 samples, right? Out of which 60% of the samples will be used for training. We are using for training. 20% is used for validation, and remaining 20% of the data is for final testing. Well, how exactly is it working, right? Now, what is the work of validation? This is something that we'll try to understand. So 60% of the data will be used for training, right? So when you are training the model, right? So in each model, each epoch, the model will be trained. Accordingly, the parameters are going to be adjusted, right? Which will finally lead to lesser amount of loss and more amount of accuracy. Now, what is this 20% data, right? Now, while the training is going on, right, 60% of the data will be used for training. And at the same time, the 20% of data which has been allocated for validation, that will be used for validation during the time of training only to check whether the training which is happening, it is happening correctly or not. Right? Whether the one which you are expecting that the validate. So when you train, the expectation is if you are going to have a good model, so accuracy should increase. So this is a metric that we basically looked into, that in each epoch, the accuracy should increase, the accuracy, and the loss should go down. The loss should go down, right? So the final total cumulative loss or the error should be reducing with each and every epoch, right? So when you do this kind of while training only, if you do that validation, you'll get an idea. So now in first epoch, 60% of the data, let's say that there are some stages of data from 1 to 60, and here you have some data that is from 70 to 90, let's assume. So in the epoch 1, right, So this was the training set for the values from 1 to 60. And in the validation, you have values from 70 to 90, right? Now, in the epoch 2, what will happen is, randomly what will happen is this 70% data that you are seeing, this 20% data, this will go into the training set. Maybe there will be some set of data like from 30 to 90 will be used, data will be used for training. That comprises 60% of the data. And here for validation, you are making use of 1 to 20, right? And this is going to be randomly allocated. You are not specifying anything as such, right? And this is how the model is getting trained, and you are creating a model. And finally, which the expectation is the performance metrics. These are the performance metrics. In this performance metrics, the expectation is the training accuracy should go high in each and every epoch, and the loss or the error should go less. It should reduce, right? And this is how the validation happens. I hope all of you got it, right? And this allocation of training data samples and validation samples will get modified in each and every epoch. Hello? And there is something called as testing data. So this is something your model has never seen, right? So this is something your model has never seen, right? And once the model is trained, you have created a model. Finally, you test that particular model using the remaining 20% testing data. Okay, so that's what is a difference between training, validation, and testing data. One second. Okay. Anyone who has a questions? Anyone who has not understood, or anyone who again wants to understand what exactly is the meaning of validation? All right. So moving back. All right. So we have created the sine wave. So that's done, right? So now what you're going to do is, so we're going to split 1,000 samples based on the settings that you have done, the initialization. So number of data should go for training, testing, and all those things, right? So you're going to do the validation split, testing split, and trend split, right? So that's what you're going to do. Training, validation. Yes. Anyone who's okay? All right. So now we'll decide upon. So what is the validation split? Okay.
Excuse me, sir.
Yes, please.
Sir, if you are taking only training and testing, not
Okay.
considering validation, so is there any problem to
No,
achieve
this is a
better
standard.
accuracy?
No, what happens is if you are using validation, so the model that is going to get created, which will be much more robust as compared to if you split the model into test and test and train data set. Now, one of the major reasons why we do create a dev set or a validation set is to figure out whether during the time of training is any kind of overfitting or underfitting is happening. Hello.
Okay, sir. Okay.
So this is something which is also used in industry. So we always try to segregate the entire data set into trend, test, and dev set, or basically the validation set. Because when you do that, so the model is randomly getting, so in each and every epoch, there will be different sets of data that the model will be seeing, different scenarios the model will be seeing, which will make your model much more robust and much more much more accurate model, prohibiting underfitting and overfitting conditions.
So if you are not taking the validation, overfitting, underfitting may happen.
It is going to happen, sir. Even this also, I am not guarantee that it will not happen. It will happen, but you will come to know that where exactly the overfitting is happening.
Okay, sir.
Because when you do that, every stage in the epoch, we are going to see the validation loss, training accuracy, validation loss, training loss, right? From there, we can get an idea. All right.
Okay, sir. Thank you.
Yeah. Okay. So now what you're going to do is we're going to split the models, right? So first validation split, I'm going to split it into the ratio that was defined as 0.2 into number of samples, right? And you have to typecast it into an integer. So you are typecasting it into int, right? And test split also, we have defined the test split. Uh, that is validation split plus test split test ratio into samples, right? And you have to print the validation split. Now what you're going to do here is we are going to decide here. So we're going to create some variables. Okay. So x underscore val, x underscore test, and underscore train, that is increase or split x values. So this is this we are doing for splitting. All right. Okay. And if you want to check whether the split which has happened, if you add all those things, it is equal to the number of samples. That also we can do. Okay. And now what you're going to do is you're going to plot. So now let's execute this line of code. It's fine. So there's no error as such. So this, if you do the asset to test whether LHS is equal to RHS, so it is fine. So when you add this up, it's coming up to be 1,000 samples, right? So I'll just share this split code in the chat. Okay. And now what you're going to do is, so whatever segregation is happening, we'll try to label each of these data points with color coding, right? So we'll try to do that out of this. So now here you can see that there are 1,000 samples in this sinusoidal wave, but we cannot say out of this, we cannot identify which all points are validation points, which all points are test points, which all points are training points, right? So we can create a plotting wherein we can check which are points that can be used for validation, which are points are used for training, and which all points are used for testing, right? So we're going to do plot those data for each subsets, that is train, val, and test. Okay, so you want to do that plot. Okay, and train. Okay. LT.show. Okay, so what you're doing is the amount of data that is kept for training, that is X is the input data set, Y is the output, right? That is marked as B. It will be, the dot will be in blue color, so it will be labeled as train. Then test data will be indicated by red points and labeled as test, and validation points will be labeled in yellow, right? And the label is given as val. So when you execute this, So you can see this. So now you can segregate and identify which all points are kept for training, which are used for testing, and which are used for validation. The validation and train, they are going to be changed interchangeably with each and every epoch, right? So the splitting happens like that. I'll share that code with you guys. Okay, can I chat? So in the chat, I did paste the code. So okay, I hope all of you are getting this plot. Okay. So next thing what you have to define, since you're going to create a deep learning model, since you are using this libraries like TensorFlow and Keras, these are deep learning frameworks. First, we have to define the model architecture. Okay. So in this cell, what you're going to do is you have to create a model architecture. Okay. So first, it is going to be a sequential model. Sorry. Sequential model. Okay. So then what you're going to do is in the sequential model, we are going to add the layers, right? So whatever is mentioned here, so we are going to add 3 layers, right? So we're going to add these 3 layers. So the 2-3 dense layers. So the activation function that is being used in each of the layers in the first 2 layers is ReLU, that is rectified linear unit. That is one of the activation function. So you have other activation functions as well, like sigma and tanh. The one which you are used here is ReLU, right? Okay, and you can execute this. So once executed, if you just want to see the model summary, right, you can just copy and paste this code here. So, sir, why it is ND array? Because it is representing an n-dimensional array. So ND is basically n-dimensional. N can be 0. N can be starting from 1, 2, 3, likewise. Right? So, but the data type has a standard name, that is n-dimensional array. ND array we call it as. So dimensions can start from 1 onwards. Right? I hope it is clear. Just copy and paste this code. I've already sent it again. Okay. Now, if you want to see whether the model which is created, I just want to summarize that and then see that in the form of a report. We can do the model.summary in the so use this function API. So it will basically give you, right? So what are the different types of, what are the different layers? Input layer, middle layer, output layer. This is one layer in between, and you can see the shape, right? They say basically represents number of neurons and what are the total number of parameters in each every layers that has been used. Okay. So these are total parameters. These are the trainable parameters. And this, so when you train a deep learning model, what exactly gets modified so that the objective of ours will be met, that is increasing the accuracy and decreasing the training loss or the error, is by configuring these parameters, right? So in neural network, that is something called as forward propagation and backward propagation. So during the time of backward propagation, these are the values of each of these parameters are basically adjusted so that the accuracy increases and the loss or the error decreases. That's what. No. So I hope this one you can type it, right? And this is going to, can anybody tell me that this model that you are going developing here, that is going to basically predict if you give some values in the sinusoidal sine function, it is going to predict a value, right? That's what is going to happen here. The model is going to predict something, and there we are going to know what should be the actual value and what is the predicted value. But based on that, we figure out how our model is working. Now, can anyone tell me, is this problem statement that we have taken up, is this a classification problem or it's a regression problem? Yes, it's a regression problem because you are actually predicting real numbers. You are not doing any classifications as such. Okay. So now, next step is we have to add the optimizers, the loss functions, and what is the metrics that we are going to use to see loss and all, right? So when you're compiling it, that's what. So we are going to do that model while compilation. So this optimizer is we are going to use as RMS prop, mean squared error, because it's a regression problem. Matrix is a mean absolute error. So based on that, right? So you have not started the training as such, but prior to that, you have to first create a model, right? You have to create the architecture. So expected model should be like this, right? So you have to create the architecture first. Then you have to set the optimizer function, the loss function, and the metrics. So during the time of compilation, these are going to be used. And then next, what you're going to do is you're going to, when you execute this cell, you are going to train the model, right? Okay. So we can just model.fit. Okay. So this fit function is used to basically train the model. So we can just xtrain, ytrain. So number of epochs is 100. So what you can do is you can make it as 500, and the batch size I can increase it to, sorry, batch size increase to 100. For validation, we are going to use xval and yval. We know that 20% of the data is going into that, right? So while you before you start training the model, so these are the parameters that you need to pass. So which will tell the compiler that the interpreter that, so while you are training the model, what are the input data, what is the x label, what is x input data points, what are the y label, the number of epochs that it has to perform. So what is going to be the batch size at 100, and for validation, which all data sets has to be used, that is xval and yval. So this goes as a parameter. So when you start training it, these all things will be kept into consideration while training is happening. All right. Okay. So I'll just copy and paste this code. All right. So now, once you start executing this, so it starts. So you can see this. So when the training starts, so when the epochs are running, so what was the loss, right? And what's the validation loss? You can see here, right? Um, MA is the absolute error. So you can see that. So what is expected, this value should reduce, and you can see that in each and every box the values are getting reduced. And if you see the values here, uh, the loss, the training loss as well as the validation loss, they are quite similar. They don't have much of a difference, slight here and there. So that means that the models are not getting overfitted. That's a good sign. So this is how we identify while training in each and every epoch. If we monitor the training loss and the validation loss, if the values are somewhat near to each other, so that basically represents that the model is not overfitting. So it'll take some time, or is it done? Okay. So now you can see that after 500 epochs, in mostly each and every state, this is represent the training loss, the values, and the validation loss. They are very close to each other. They are almost not that, the difference is not that huge. That means the model is not overfitted, right? So how to handle overfitting? Then, so thing is that if you have to handle overfitting here, you have to again reiterate back. So you have to basically do modifications here in selecting how much amount of data you want to go for training, what kind of activation function you're going to make use of, how much amount of data should go for validations. So it's something that is there. And apart from that, there is a technique called as regularization techniques, which also helps on us in handling this overfitting schemes, right? I hope all of you. And if you guys want to track in the form of a graph, you want to see how in each and every epoch the loss curve looks like, right? So that will also help us in giving it a loss. The training history basically we want to try to plot. So let's plot the training history. So loss is equal to so history of loss. Validation loss is history of val loss. Right? Epochs, you have plotted this one. Okay. So you have to plot plt.plot epochs. BO, right? Training loss, validation rod, validation, region, and show. All right. Now when I execute this piece of code, so it will basically show a graph. You can see that the line basically represents the validation loss and the dot represents the training loss, and they are somehow reducing, and they are in the same line, right? So there's no much deviations. So this is a good sign. It's a good sign basically. So it was in the 6th epoch. Just check in the other epochs. Avinash, you can just see there are 500 epochs. So it is basically going to be retrained for 500 times, right? So in order to avoid this overfitting as well. So just check in others. Right? So the one which we have trained right now, you can see that they're on in line with each other. That's a good sign, basically. Not val MAE. It's basically I'm talking about the training loss and the validation loss. That you just have to monitor these two. The training loss and the validation loss, not MAE value, mean absolute error. I'm just asking you to look into this training loss, this one, and the validation loss value. They're close to each other. Not the validation loss and validation MAE. If you have to find out whether each and every epoch when the model is getting trained, whether any overfitting is happening or not, you have to basically monitor the training loss and the validation loss. And after that, you can also plot the graph like this. So you can see in this graph, along with the training loss, the validation loss is also happening. There is no much deviation. That shows a good sign that the model which is created, it is going to give you accurate, mostly accurate results, near to accurate results. Avinash, did you see that? So you are checking on val loss and this one. 0.1593 and 1673. That's okay. It's not that difference, right? So you try to plot this graph, it will give you a much more better idea. Just copy and paste this. So this is going to give you much more clarity. Okay, so training is done, right? Now what is that if you remember that we have divided the data set into three parts. One is training and validation as well as testing, right? So now what you're going to do is you're going to feed in values which the model has never seen, which are basically segregated and is kept in this particular n-dimensional array, one that is X text, right? So now we are going to test the model using the data set that is X test, and we are going to see what is the actual value and what are the prediction values. Are they in line with each other or not, right? So that's what you're going to see right now, right? Now, along that, we're going to plot also the predictions, right? So predictions. Predictions is equal to model dot predict x underscore test, right? This is what you have to give. And then we will try to plot also. So whatever 200 data, the points that we have kept, that will be represented by, so if I just use this entire thing, so the actual data points will be represented by blue dots and the predicted data points will be represented by red dots, right? So you have to plot a graph and you can see, and I'll just plt dot show. All right, and execute this. So you can see that almost there is no much, the red dots that you're seeing, these are all predicted values, and the blue dots are the actual values. So you don't see much of a difference. You don't see much of a difference. You don't see much of a difference. So further, if you want to further validate, what you can do is, I hope you are getting this. Just paste the code here. All right. So okay. So if you have got this kind of graph, that's fine. Now, further you want to validate. Let's say that sine of 2. Can anybody tell me what is the value of sine of 2? So what we can do is we'll try to predict using the same model that we have trained, and we are going to pass in a set of an array, right? With certain set of values that we are going to pass. Uh, okay. Uh, okay. So this is what we are going to pass, right? So these are the actual values that we are passing into the sine, and we'll see how exactly it is predicting, right? Okay, this is done. This is an extra. It's fine. All right. Now let me execute this. So you can see this. So when you are passing this value 0 to model.predict, so it is basically predicting value 0.10 something. So when you're passing a value 1 to it, it is predicting a value 0.87. So what is the value of sine 1? Can anyone tell me? Can you use a calculator? So you can just figure out, you just put a value 0, pass a value 0, we'll get the actual value, but these are the predicted values. These are the predicted values. So if you have to further validate this, so this is right. Now the next step is very much important, right? So we are going to create, we have already created a model, but this model doesn't have any physical form as such. There's no physical file it is created, right? So now what you're going to do is we are going to create a physical file, right? If you remember, we have already given a name in the settings, that is here. So in the initialization, we are going to name it as sine underscore model, right? Sine underscore model. So here what you're going to do is, so you're going to create different forms of file that represents a model, a physical file. So how are you going to do that? That you're going to see, right? Okay. So first what you're going to do is, so we are going to first create a Keras model, right? So whenever you create a physical form of a Keras model, the extension is .h file. Okay. So name, first you have to define in this variable what is the name that you're going to provide it to it. Model, right? Then what you have to do is, while saving the model, save, and that the parameter that you're going to pass is, okay, the parameter that you're going to pass is this variable. The first parameter is this variable, okay, plus extension that you're going to add to this dot h5. So when you do this, the model gets saved. So where will you check whether this model is created or not? So you can just click on this file, right? So you can see here, right? So previously it was not there. Okay. So now a model is created with a physical form. It's a Keras model file, that is .h file. But we are not going to use Keras extension here. We are going to use TensorFlow light condition. So this Keras model that we have created, so we have to this is a Keras model, right? And this is the Keras extension, right? So you're not going to use a file with a Keras extension. So what you can do is we can create a physical file, one more form of physical file, which is much more lighter version as compared to the H5 model using TF Lite, right? TensorFlow Lite. So now what you're going to do is you're going to understand how to convert Keras model into to a TF Lite model, right? Okay. So how are we going to do that? So we are going to, 1 second. Right. TF Lite. What else? TF Lite, tf.lite.tflite from Keras model. Okay. TF Lite.model is equal to converter dot. So now that is there. This one is not required. And remove this. So converter, to that we are going to apply some optimizations. Okay, optimization tf.lite dot optimize. So we're going to use a different option here. Since we are going to use it for our low power, low memory fixed point devices, you want to select this option, optimize for size, right? Then TF Lite is equal to converter dot convert. Okay. And then, okay. So model file name plus tf.lite. So here for TF Lite, we have already defined the variable here. So you can just navigate to the initialization section. So here, let's copy this, go back to the code here. All right. And here mention the, replace this with this name, dot TF Lite. All right. Okay. So once you execute this, deprecated. Oh yes. So you can see that a new file is getting created, sign underscore model dot TF Lite. Okay, so it is created TF Lite model. Now, if you want to visualize this model, how this model is like, so there is a software called as Netron. Okay, you can go to this website Netron. So go to the GitHub link, right? And I'll just share this link with you guys. See the model, the physical file. I've shared the link, right? So inside this, just scroll down. So if you're using a Windows, you can download the installation file, which is having a .exe format, right? For me, it is already, I have already the same thing in my system. So you can do that and you can install it. If you're using Windows, try to install this .exe extension installer downloaded, right? So since I have got Netron, I'll show you. So this is basically used to see the model, the okay. So this is something this looks like. So what you can do is you can download this. You can go back to Google Colab, right? And here you can go here and you can click on these three dots. It will give you a download option. Just download this. Okay. So once it is downloaded, so what you can do is so go to Netrum, open model, go to downloads and wherever. Okay. So this is a sign model, right? So you can see that so whatever model that we have right now, right? So this physical file, when you put it, you will get the entire model. So you can just magnify it, and you can each and every layer, you can get the description, the model properties, right? So what kind of parameters, what is the data type of those parameters? So here weights and biases, right? What are the parameters for weights? What's the parameter of biases? What type of data type it has, right? Then second layer of you see also it is having a shape 16 cross 16. Then the data type of the parameters are float. Bias data parameters are also float, right? Now if you go to the fully connected, here also it is float, weights and biases, right? So this particular software will give you an idea about each and every layer, the properties of each and every layer that you have incorporated when you are creating or training a model. But why did I do this? There is a reason to this, because at the end of the day, what we are going to do is we are going to host this. The model is created, but we are going to host this model in a microcontroller which is having low memory footprint, right? It doesn't have that much amount of memory. It's very constrained. Resources are constrained in that we are trying to host this model for inference. We are just going to use this model for inference. So just what? So, but we are not training the model in the microcontroller. The model is already trained in our host system. The only thing that we are going to do is we are going to whatever model which is created, the TF-Lite model which is created, that has to be transferred somehow to the microcontroller, and after that the microcontroller is going to do the inference, the predictions basically. Okay, so if so in this the predictions will be, so you are going to give a value to the sign function and it is going to predict the value for you, right? That's what is supposed to happen. Now if you carefully observe each of these models, right, they're right, so you can see, right, all of this, the parameters, data type, if you see, it's all right, all those things. So what do you think, the model which is created, do I still need to optimize this? The question first it comes is, after observing each and every layer and the parameters with respect to the weights and biases of each and parameters that you're seeing here, what do you think? Do we need further optimizations? Do you need further optimization? What do you think? Is it required? Do you need further optimizations? Now you can see that each parameter data type is floating point data on size is 32 bits. So there are many parameters present, right? Don't you think that because for storing each parameter you need a variable, and the data type of each variable is what? It's a floating point value, and that too the size is 32 bits, right? So do I have that much amount of memory to accommodate all the parameters for doing the inference? No. We cannot do that. Right? Now, somewhat what you have to do is you have to truncate this particular value. Somehow we need to find out a way to convert these data types to 8 bits. So you have to truncate it. We don't need 32-bit of data. We have to truncate it. Right? So we have to truncate it, and after truncation, we are going to create a header file. Right? We are going to create a header file which is derived from this TF-Lite model, and that header file will be used in our firmware, wherein we are going to host the, I will use the firmware used in the firmware for hosting the TF-Lite model in a microcontroller, right? So here what you're going to do is, so you have to further optimize the code here. So after observing, we see that the parameters are too, the size for each of the parameters are too high to be basically kept. There is no much space for that in a microcontroller, right? And so what you can do is, so we are going to create a function that is going to convert. Right, so don't. This is a function we are going to do. We will further optimize it to convert it into a header file, and we are going to call this functions from here. So when you do that, we are creating a header file, and you can see that a .h header file for a C program is created. Now, if you just download this, right? If you just download this, if you see this in the notepad, can you see that? This is your model parameter values. And one thing to observe, this is an header file, right? To observe is what is the data type. It is unsigned char. You can see the total number of parameters is 3168, but the data type is now truncated to unsigned char. That is nothing but 8 bits, which was basically in case of TF-Lite, it was what? It was 32 bits. It's a floating point data, which requires higher precision and computation. But here we have somehow converted this into a integer value. The data type is now truncated to unsigned char. This is the header file. And this basically is going to be used in the firmware for hosting the model. This is what the model, which is in the form of a C header file. All of you are getting it? I hope you will be getting this .h file. So you can download this as well. It's already downloaded, and see that how exactly it works. All right. So, Srishandu sir, can we take a 5 minutes break and then we'll go to the next case?
Am I audible, sir?
Yeah, can you take a 5 minutes break
Yes,
now?
yes, yes, sir. You can take 5 minute break. And,
5 to 10.
so after 5 minutes, we'll again start. Okay. Yes.
Okay. All right, I'm audible. Can you guys hear me?
Yes, sir. Audible, sir.
All right, we'll resume the session. So Ishan, sir, just acknowledge whether my screen is visible or not.
Visible, sir.
All right. So now we have successfully from Python file. After that, just okay. So we have successfully created a header file, a C header file, and we are going to incorporate this C header file for the firmware that is going to be developed in order to host a model, an inference model, a machine learning model uh, in a platform. So first, we need to know which particular hardware platform that you are making use of. That's basically it's a development board from ST Microelectronics. So STM32 for discovery board. So right. So if we go to the official website, I'll share the link also. So in the chat. All right. So I've shared the link of the hardware platform. So this is the board that we are using. So it's a development board which is having a microcontroller that is STM32F407, and in it you have, if you look into the specs, the specifications, it is having a processor from ARM. It's a 32-bit processor, and along with it belongs to Cortex M series, that is specific is M4, with a floating point unit FPU. So as I was saying that when you talk about microcontrollers, the resources are constrained. That means the amount of RAM and ROM. So in this case, the ROM is nothing but your flash memory, that is 1 megabyte, and the amount of RAM is 192 kilobyte. Right, this is a RAM. Right, this is what you're going to use. Amount of RAM. So it's very limited, very constrained. So in that, so we have to basically ensure that we have to create a binary file which will be uploaded, which will be having the model that is nothing but the header file that we have created in this particular specific within this bound, that is 1 megabyte bound size. Right now, so how exactly are you going to configure? How are you going to do that? This is the second phase of this hands-on session where you will get an idea. right? How to host it. So, so if you have to program the microcontrollers, STM based microcontrollers, right? So we basically do one thing. First thing that what we do is we use an IDE from STM32 Cube IDE, that is from ST Microelectronics itself. So it's an integrated development platform, Eclipse based platform, which can be used to write firmware for this microcontrollers. So I hope all of you have installed this software. So I already have it. So if you don't have it, then I can also give you the link. So afterwards, you can download this. Download. So this is a platform we have. All right. So if you just get software, go to say software. Okay. So now here here you have installers for different operating systems, right? So yes, Debian based, Linux based, Mac based, and Windows, right? So depending upon whatever operating systems you are using, you can download. The latest version is 1.17.0, all right? And you have the previous versions also, which are archived also. You can also download that as well. So preferably, I hope most of the participants out here, so they are making use of Windows operating system, so they can download the last one, right? So it is free. It is nothing like they want to charge you anything as such. So you just have to accept this, right? And just download as a guest. Just do that, right? Give your name, your professional email, get a link of the download, and you can start downloading it. That's all. So already we have it, right? So we don't have to take our heads on that. And I hope you guys also have downloaded, right? Okay. Now I'll just show you. So I have this. So when you click on that, so it will first ask you for the where exactly are you going to store this particular project, right? So we are going to store this project. We are going to create a folder. So I have created a folder FDP demo, right? Accordingly, you can browse, go to my computer, go to F drive. So here we have, I have created a folder, but you have to select a folder. You don't have to select a file. So basically in this stage, what happens is you are basically, your ID is searching for a workspace or a folder where your projects are going to be stored, right? So you have to select the folder. Okay. And then you have to launch the ID. So this is the first step. All right. So this is what is the ID, right? Okay. Now after that, once all of you have opened the ID, can anybody acknowledge the chat? Okay. So now what you're going to do here is the first thing. First, we have to configure the ID itself in order to ensure that we can create this whatever header file, the model which is created that can be hosted on the hardware platform that I've shown you, that is STM32F4 discovery board. Now, what I can do is I'll go to help. So I have to do some necessary pre-configurations in this software ID itself. It doesn't come, you have to do it, right? So what you have to do is you have to go to this help option, right? You have to go to this help option. And in this help option, you have something called as, there is an option, there will be a drop down. In that drop down, you will be having an option called as manage embedded software packages. Just click on this. So we'll get a window like this. Okay, you'll get a window like this. So here you have to basically select the option here. It is ST. Okay. Now you have to scroll down. Then you get an option called as XQAI. Right. So this is a package which is developed by ST Microelectronics, which will be used to host the lightweight model that we have just now created on our development board, SQAI. Right. Now you can see there is an arrow mark. So you click it, just extend that, just expand this option, and you have to select the version of artificial intelligence package that you want to install, right? So there are different versions available. So what I would suggest is the latest one is 10.0. Apart from that, if you can scroll down, there are archives for other previous older versions. You also install, select the 5.1.2 as well. Try to install these two versions. That is because there are some dependencies issues in 10. So try to have both of these, the latest one as well as the one version number that we're talking about, that is 5.1.2. Okay. So, right. So I can, if you just keep on it, it will tell you that this is there, right? Okay. So for me, it is already installed. So if I will show you, if I want to install another version of this, I want to install 9.1.0, I have to select this. So you can see this install button out here is highlighted to blue right now. So previously it was not highlighted because I haven't selected anything. So you do the check it and try to install it here. So as soon as you do that, so some necessary packages will start getting installed, and I have read, and you have to accept to this agreement. Okay. So it's done, then you can close this. Okay. Right now, next what you are going to do is you are going to create a project. Okay. So first click on file. All right. And then the first option that you are seeing is new. So the drop down will come, and from there you have to select this project called as STM32 project. So it is basically it's going to give you, initialize you, window will pop up which will allow you to select what hardware that you are going to use, because ST basically develops microcontrollers. They have different families of microcontrollers. The one which we have is having a microcontroller that is STM32F407, right? Now here, before you start selecting it, there is something that you have to select. Here is the AI package. Okay. Right now you can just see that after you have installed this, automatically in the middleware this option will come. So if you have not installed the AI XQ AI package, this option will not come in the target selection window. So for me, since it is already installed, right, so I'll just expand this, and if I enable this, so you can see right now it is not enabled by default, right? I have not checked the option yet. Okay, you have to manually do this, right? And once, if it is not manual checked, at that point of time, you can see total number of MCUs or MPUs that can be selected. This is the entire line of products that is manufactured by ST people, ST Microelectronics, right? That is 4,416 items, right? So as soon as I check this, enable this, you can see that the value has decreased right now. That means that you have my MCUs and MPUs, not all MCU and MPU, microcontroller and microprocessor unit, so will support, the architecture of their controller will support a AI model to be hosted on the top of it, right? So you have out of 4,400 or something. So if you just disable this, so the total out of 4,416 microcontrollers and microprocessors, that these are the list of items that only support AI model, lightweight AI model that can be hosted on a microcontroller or a microprocessor unit, right? But once you have enabled this, now we have to select our specific board, right? We already know what our board is, right? So in this, go to part number. So here you have to select STM32F4. sorry. I have to select here. Yeah, F407. Okay, so as soon as I select this, so you can see that the one which I have showed you right previously in the browser, if you remember. So if you remember that here I showed you right is the board, right? So it is same as that of this one also. So you have to select this board. You have to highlight this board. So as soon as this gets highlighted, so then you have to press next. Okay. And you have to do what? You have to give a name of your project, right? So I'll just give the name as AI test, right? And after that, the targeted language is C. It is going to execute a binary executable, and I'm going to use this package STM32Q. Okay, so you're not going to make modifications to this and press finish. Yes. So if you get an option like this, press yes. Take some time. Okay. So you're going to get a IOC file. So which here you have to do some pre-configuration. So first thing that you have to configure here is a timer, right? It will be showing you what all peripherals here. So in this timer peripheral, you have to select any the timer, that is, we are going to select timer 14. And in that, we have to do some configuration. So first, you will not see any configuration settings. So what you have to do is you have to check the activated sections. So as soon as you see that, you can see that you can set the pre-scalars, clock period, and all those things. So here, what you're going to do is, so here we are going to select the pre-scalar to okay. So accordingly, the counter period is selected to 65535. This is the basic configurations that you have to do, right? So in this case, right? So the auto reload register will get a value, right? That is this one. So when you're setting the prescaler to 79, that is 80 minus 1. Because why you are doing it? Because we need a clock of 80 megahertz, right? So the clocking should have, the instruction execution should happen at a clock of 80 megahertz for this operations, wherein you are expecting that a AI model will be hosted on a low power device like a microcontroller, right? Okay, so this is done. Okay, now what you have to do? So this is done. Then you have to do some additional settings. Hello. So now what you have to do is you have to go to the software packs, right? And there what you have to do is you have to go for this select components, right? This window will come up, right? Now, if you have installed this, if you remember that previously we installed this package that is SQ AI, right? Yes or no, right? So once you, now again, I'll show you what you have to do is after configuring the clock, then you have to go to software clock. There's a drop down here. So you'll get two options, select components and manage software packs. So you have to go for select components, click on that. So you're going to get a window like this. In this, you can see there is an option that is present that is called as Xcube AI, the one which you had installed previously, right? Right? So get a drop down of this, and right now the version which is selected is 10.0.0, but we have installed 10.0.0, why it is showing? Wait, I think 1 second. Actually, we are supposed to use 5.1.2. Let me check. Close this. If not, then go to help again. Go to software packages. It's installed. Why is it not showing this here? Again, install this. All right, we can again reinstall this. Just 1 minute. So some issue is here. All right, I can check. All right, Xcube AI. Yeah, you can see it's now available, right? So you don't have to select 10 point, you have to select this 5.1.2. Just expand this, right? So there are two options here, that is Xcube AI and applications. So expand this application, select this core. Okay, select this core, right? And here for applications, we are not going to use anything as such. You don't touch upon that. And after that, once it is done, you have selected the core for 5.1.2 package. You can press OK. Right. So it's some install some files further. This will take some time. All right. So that is done. So once this is done, okay. So right. So you can see that now in the additional software, right? So go to this software packs, right? Right. You can see there is an XTIP Cube AI for you, right? 5.1.2 version, right? So here what you have to do is, okay. So you have to add a network, right? The network that we have created, right? Network model, right? TF Lite model that we have created, right? And we have downloaded it as well, right? So I think we have downloaded it. Let me check. Yeah, TF Lite model is downloaded. So here, so you have to add that particular network here, right? So as I click on this, right? As soon as I click on this, so you have to give the name of that model, sign underscore model, give the name as sign underscore model, and what type of model that you are basically importing in this SCube ID. That's a TF Lite model you are importing, right? Okay. And you have to browse for that particular model, right? Browse for that model. It is in downloads. This one. Just select this, right? So once this is done, so you can see that once that is done, so you can see in here down, so you can analyze this particular model as well. Okay. So once you click on this analyze, it will give you the details about this model. Just it is analyzing it. It will show you the model layers and everything. Okay. So this was what the layers said. These were the parameters. It is matching the one which we have seen in Netron also. And when you did model.summary, if you remember, we did model.summary here, right? We also have the same data. Where is model.summary? Is after creating the layers. So the neutron, sorry, not here, the neutron thing, right? So we are getting the same data, right? Of the test model. Now, if you can also see the graph here as well, the one which we have visualized in neutron, you can also click on this. It is going to talk about detail about the graphs, each and every layers, right? And the C graph also you can see, right? So what all the memory usage, right? And the great thing about this is, so it is going to basically see what amount of memory that is going to occupy is 1.25 kilobytes out of 1 MB of flash, and RAM is 126 bytes out of 112 kilobytes of SRAM, right? And you can also validate the model in the desktop, right? You can also validate the model on the desktop as well. So it is validating the model whether whatever model that you have imported is correct or not, is working or not. It's validating in the x86 processor. Yeah, validation is perfect. It is fine. All right. And you can also validate it for target as well. All right, you can do that. Now, as the configuration is not yet over, the next thing that you have to do is, you have to do the clock configurations, right? So the final objective of this clock configuration is to ensure that the clock that is applied to the cortex, right? The clock that is applied to the cortex clock should be 80, right? So here you can see that here what is happening is, here the clock supply is from HSC. You have to make it HSI, high speed internal, all right? And you have to make it HSI, right? And you have to make this value of H clock as 80. Okay, 80 and press enter. Okay, H clock as 80 and presses enter. But you can see that when you do that, actually it just hang. 1 second. So when you do this, we'll try to automatically adjust. It will try to automatically adjust, but somehow you are not able to get the value, the clock supplied to the cortex as 80. It is 336, right? But it could be 80 megahertz. That's what it should be, right? So what we can do is, we'll try to utilize the same thing. We'll try to do control S here, right? And with this configuration, we'll try to show you how exactly the project explorer gets modified, what a new folder gets added, which is responsible for hosting the AI model, right? So press yes with this clock configurations. Yes. So you can see that a new folder gets integrated, that is XQ AI. So once you go inside this, you can see all this sign model.c file. That's a C file, and the sign model.h file, which is derived from the TF light only. Okay. Now if you see the sign model.h file underscore data.c file. So one which you remember that we have done that, right? So here also using this, now once you generate, this gets added up, right? But the application that we want, that has to be basically written in this file, that is main.c file, right? In the main.c file, right? So actually this platform that we are using, that is some problem with this configuration settings. So what I can do is, I will share the code with you, but this is the basic prerequisite that you need to understand. Ensure that you get the necessary xcube.ai.c.h files. And after that, for building the applications that is going to do the predictions for you, you have to basically modify the uh, modify this file, that is the main.c file. So I'll share this modification with you guys. Right now, actually, it is not working because of the configuration issues. It is why it's not happening. I have to check. So, but the code that is there, I will share that code with the coordinators, and you can accordingly make the changes and try to create a hex file and see the see the entire process. All right. Sri Sindhu sir, can you hear me?
Yes, sir.
Yeah, sir. I think I'm done with the session, right? And
Okay.
yeah, I'll share one file with you. You can share that
Mhm.
with the participants, so accordingly they can make the.
Yes, definitely.
Yeah.
So participants, any questions for the session? Anyone? Anyone can ask a question and also can write in the chat box also. So I hope there is no question
All
for the
right.
participants. Okay, so thank you, sir. It was a wonderful session on how to implement machine learning algorithms using Google Colab to embed systems. I hope participants will get an overview of this technique. So it was a very nice session, sir. Thank you. Thank you very much.
Thank you, sir.
So I think we can
Thank you, sir.
end this session. We'll share the feedback link. Okay. Uh, the feedback link will be shared uh, through WhatsApp. I hope all can fill the feedback form. So thank you, all of you.
All right. Thank you all. So I'm leaving the session.
Yes, yes, yes. Okay.